Hi, my name is Shirley Davidson, and I am majoring in math and data science. For my presentation today, we are going to be talking about a type of neural network called autoencoders. Autoencoders are all around us, even if you don't realize it. They're in our phones and are used when sending images to other people and getting images off the internet. A neural network is a tool that aids in the classification of data points for machine learning. Autoencoders are a type of neural network that are capable of learning large amounts of data without being supervised by labeled training data. We use autoencoders to help with the curse of dimensionality, a common data science problem that involves the excess number of predicting variables. Autoencoders can build models while using the most important information. There are many different types of autoencoders, but for the purpose of my presentation, we are just going to be looking at three different ones: stacked, convolutional, and denoising autoencoders. Each one of these autoencoders has an encoder and a decoder, the different sections of an autoencoder. A stacked autoencoder has multiple hidden layers, whereas convolutional and denoising only have one. All three are really good for images, but when it comes to images that have large sizes, a convolutional autoencoder works best. A denoising autoencoder is used on images if there are missing or blocked portions of your images. The denoising autoencoder actually recreates the missing or blocked image. When looking at the three different types of autoencoders, we want to analyze the results to see which one performs better. We will apply these autoencoders to an image classification problem, intending to achieve data compression. In order to test the accuracy of our models, there are several ways. For example, we could pull up the original and the recreated one from the autoencoder and visually check to see if there's a difference between them. We can also compare the change in pixel value. Each pixel of an image has a value according to the RGB scale. In comparing the same pixel from the original image and the reconstructed image, we would be able to get a quantitative difference between the two images, allowing us to check our accuracy of our model. In preparing to compare the different autoencoders, we needed to have an idea of something that we wanted to test. In this case, I wanted to see if an autoencoder can pick out the different buildings that are on Carroll's campus without letting the autoencoder know which buildings they are. In order to do this, we needed lots of images of Carroll. We needed to pre-process them and run them through the different models. In getting the images of Carroll, I contacted Jeff Wald, who takes all of the marketing images for Carroll. All of the images that were given were the incorrect file type for an autoencoder. So part of the pre-processing was changing the file type, resizing them, and creating new images based off the old ones by rotating them, zooming them in and out to get more images. In looking at the outlines for the three different models for each one of the autoencoders, we can see that a stacked autoencoder there has two hidden layers, both with 30 nodes. The convolutional autoencoder has 3 convolutional layers with one hidden layer of 16 nodes, and the denoising autoencoder has a dropout rate of 0.5 along with one hidden layer of 15 nodes. With every model, there are challenges, and when dealing with an unsupervised learning model, there is no different. It is no different. In coming up with an idea for an autoencoder to pick out the different Carroll buildings without letting the encoder know what they were called, we ran into some trouble in having the model read the images correctly. Past models have used supervised learning where the encoder knows what the input is, or called labeled, usually by passing in a data frame. Other types of challenges that occurred were pathway issues where the model was not looking in the right spot for the images. In order to move past these problems, we are going to need to use different techniques for implementing unsupervised learning, which entails knowing how to read the image outside of a data frame. Autoencoders, as mentioned before, are all around us, in our phones, sending them, getting images off the computer or internet. When looking at autoencoders, we should be looking for a really clear image that is made up of the least amount of information from the original image itself. After I'm able to get working models, we should be able to see the autoencoder cluster the different Carroll buildings together, along with compress the original images. Here are my citations, and thank you for listening.